Hi there. Okay, so I'll just start. Hi, my name is Emanuel. I'm a principal engineer at Infobip, and today I will talk about our journey of making a Copilot for UI-based chatbot builders. And actually, to tell you, we started with prompting, and hopefully then in the end you will learn something and see okay, this wasn't enough for us, so we ended also somewhere else and did a bit more than just only prompting. Okay, but when I say Copilot, what does this actually mean? So Copilots, this is now a generic term where when you say that kind of functionality, it basically means some AI feature which uses large language models to translate some natural language text into some meaningful action. It does something. And this is, I would say, the recent trend where companies, software solutions are trying now to make those kind of features, and it looks like that, okay, users will anyway expect to have something like that. Good. So, okay, this doesn't work. I will have to just use my laptop. Maybe somebody, oh, okay, now it works. Okay, but when I say Copilot, and I mean, you probably already know. You know, all those examples, like GitHub Copilot to generate code, Midjourney to generate images, Microsoft Office launched a Copilot, Windows also now their own Copilot, and this is the trend. So every, as I said, solution company will want to have one. And if you would like to, okay, I'll just stick here to the laptop. This doesn't work. So if you would also like to make your own Copilot, this is, I would say, a pretty interesting research paper which nicely summarized, you can read it later, which really nicely summarized the whole process of making the Copilot. And I would say the most important things are here that you know your own business scenario, that you have the necessary data actually to train and evaluate the model afterwards. But there are a lot of things that you have to think about. And okay, with that, I think I can skip my talk, right? So you have everything here. But I think, I'm not that lucky. So anyway, so this is what we did. We also looked around, what's the process, and let's do our own Copilot. At the case of Infobip, so for instance, one of the products that we have is basically allowing our users to create chatbots. And we allow our users to do that with an UI. So basically, you have visual elements that you can drag and drop and define your chatbot logic, how the chatbot should behave. And okay, this works. You can do a lot of here things. And like here, drag a descent element, write what's in there. But we wanted now to move beyond that and actually allow our users to say, hey, here, write really what you want. I want a chatbot for a banking app. I want some behavior that sends a message, calls an API, does something, and then just poof, magic. Hey, okay, here is my chatbot, and then either I'm already finished, it's configured, or at least I bootstrapped my chat building, and I'm going to be faster done. And in our case, so like here on the right side, what you see is those are those visual elements, but in the back end, so it's basically, those are code blocks with domain-specific labeling, a configuration that can be transferred like a JSON or any other markup language. And so naturally, what you can use, what you can start, this is what also has been said in this paper, so you can just work with prompting. So OpenAI, I would say, makes it really easily accessible, and this is also what we did. We said, okay, let's try to make a Copilot where we somehow describe how our underlying code is looking like, and when a user writes, I want a chatbot for collecting feedback, then OpenAI will generate our code, which we can directly use and just plug in and render in the UI. But the thing is, then you come basically to this task of prompt engineering. There are multiple ways now how to do this prompt. For instance, we tried several strategies. Let's say you can do the same thing. A zero-shot strategy would mean, okay, you describe your problem, how you want. Let's say in our case, we wanted to build a chatbot dialogue. We had some special definitions, and we defined, okay, this is the vocabulary. This is like, let's say, this domain-specific labels, identifiers, what we use, and any other, basically, software solution has those things. So this is what you have to put some effort into it, how to construct that prompt, which then describes what you want to be generated. Then a few-shot prompting is a strategy where, in addition to that, you also say, hey, look, here's an example of an input and the generated output. And you do like a few of those examples. And then most hopefully you will get better results. Another also strategy is you can add like specific also instructions on top of that. For instance, in our case, the UI elements that we have some specific rules. So let's say one element cannot be before another one. Another visual element can only appear once. It could be that you have some domain-specific rules that you want or need to enforce. And this is then what we did. Okay, and once you have the prompts, you would probably like to test it beforehand, before you put it in production. So this is also what we did. So we did some experiments where we said, okay, we are interested in two different things. We want to know if our model is hallucinating or how much, and how accurate it is. And hallucination is something that, again, is domain-specific. This is why this previous slide said, okay, you need to understand your domain, your business model. So in our case, what we generate and what we render in the UI has to be, so the format has to be correct. Let's say a JSON configuration file, which can be parsed. The vocabulary which is in there cannot be something which is some kind of random word, but basically some identifier maybe that we have. And again, the rules have to be validated that in the end, what gets here generated can be rendered in the UI. And the hit rating is in our case, okay, how often did we really, based on the input, manage to correctly 100% like get a match what our users have been doing, like constructing a final chatbot. And here we see, okay, with a lot of prompt engineering, testing out, we managed to get a hallucination of around like 12.63%. And this was, okay, as far as we got. Our hit rate was around like, let's say 2%. And that's that, okay, which we tried different prompt engineering techniques, but this is like where we got. And we asked ourselves the question, okay, maybe like that's that, like, but can we maybe do better? And if you say, okay, really, this is, I mean, the answer could be, this is for us enough. Let's go, put it in production, but we want to see, okay, can we maybe do it better? And one thing that you can do is basically you can take large language models and adapt them to your own data. And this is exactly what we did. So we said here, there is GPT 3.5 from OpenAI. This is a commercial LLM. There are open source variants. At that time, we said, okay, Mistral, Llama, and another one also from the research community. But we want to see, okay, there are, let's say, different large language models from their own size. This will depend later, like when we are deploying it, like how much of hardware resources we need to do or how much money we're going to spend on hosting, let's say, GPT 3.5. So we said, okay, let's test those for large language models from sorted by their size and see how good can they actually perform better. And to do actually that, so this is usually some kind of data that when you're doing your own Copilot, you have to gather. You have to know what's the input that your users, let's say, will put in there and what's the desired output. In our case, the output is some kind of domain-specific code that we then just put to render in the UI. The input are really those sentences that the user will write. So a user will say, hey, create me a location-based service that helps users do something, or hey, collect feedback, send a message, call an API, do something like that. And once you have that, then you can train your model. Good, so now we know that. And then the next thing that we did, at least in our case, we saw, okay, but we don't have that data. So, okay, then we could just cry and go home, right? Yeah, that's always one solution. Or you can do that. Or another thing is actually you can use Gen AI if you don't have data. This is, I would say, a nice feature also from this whole large language models. I mean, you have the word large in that, and this means like there is a lot of data used to be trained there. So the hypothesis, and this has been shown a few times, that you can use those models to extract the knowledge. which was used to train on them. And in our case, basically, and there are also some other examples from other people where you can say here, this is, I know, my code or my something. Please tell me like how a user would describe when that user would request something like that, or how would that functionality be. So in the end, you have to do some prompt engineering. I mean, this is not the final prompt, but you would start with something like that. You would take your, let's say, code. You would need to clean it, standardize, do some anonymization, those kind of things, and then like just paste, let's say, that raw code block, and tell, in our case, GPT 3.5, or even the 4 would be better. Say, hey, how would a user now, I know, request for something like that? But you would need to know for your domain, okay, how to do this specific prompt. But in the end, it turns out you can really then generate those texts. And once you have that, then you can fine-tune the models. When you're fine-tuning large language models, and this is, I would say, the cool thing about like when Gen AI came, you have a bunch of different tools, frameworks out there. One of the things, so I mean, if you now think about how a large language model is, it's a neural network. A bunch of different matrices are being multiplied. But one of the techniques that is being used now for, or one of the popular ones, is low-rank adaptation. So basically, you don't need to train the whole model. You only train like 2 smaller matrices who steer the model. Okay, now this is the kind of output that I want to get based on the data that we said before that we now have. And you could use, for instance, you can go to GitHub. So Hugging Face has a nice framework for this parameter-efficient tuning. You can maybe use LLM Studio. This is also, I would say, a nice tool which you can deploy on your server, on your GPU server, and upload basically a CSV dataset. It can train your model. You can download it and then host it also. So there are already, I would say, from the community, a bunch of different interesting solutions that you can use to train your own model. At least from the open source side. For the commercial side, from OpenAI, you would need to go from their own API. But here you have a bit more control if you dive in more into the intricacies. Okay, so now this is what we did. We had all of those, with that data, we trained our fine-tuned models, and we put them to test to really then again like generate a chatbot to see like how good can we now generate those, predict those visual elements. And here, this is for me, it was really interesting that when we saw this experimental results. So we managed actually to reduce the hallucination to 0.04%. So if you remember, it was what, like 13%, like it was the minimum with a lot of prompt engineering. And here, like, okay, we are really good. Actually, Mistral it still like had a bit higher of a hallucination, but it had the best, again, like accuracy. And if you remember the hit rate, it was around like, what, 2%. Here now we are achieving like almost 20% hit rate. So it's significantly higher. And again, like with more data, with more continuous work on that, and with now newer models, the Llama 3 came out, so probably this is the next thing that we're going to do. You can be even better. And here, our interesting thing was, so you see like this small model. This is actually a really efficient one. They took the people who worked on that, I think from Princeton, they took Llama 2, 7 billions, and then like pruned it to only make it really efficient, and this really exhibited nice performance. So this just shows you sometimes maybe you don't need the really large, best performing one. Maybe it could be that a smaller one also works for you. But you have to do the experiments. You don't know that beforehand. Yeah, and oops, sorry, my clicker. But as I said, so let's say in the case you used, you now trained your models. Also from the inference side, you want to deploy them somewhere. There are already like, you can use Hugging Face text generation interface framework to deploy them. In our case, for instance, this is what we did with, I mean, this is the code block for running, let's say, the model that we trained on LLM Studio. So it's basically a one-liner. You just have to have a GPU that you can use. For Mistral, we had to use Llama CPP, so we had to convert it in another format. But again, like it's not like too much of a problem. And this is, I would say, this interesting thing. So if you see, okay, depending on the size of the model, you need a GPU which has like more VRAM. And in our case, okay, this tiny model has exhibited, I would say, a nice performance, but it needs only 5.8 gigs of virtual RAM in our GPU. But if you say, okay, let's now this works, and we want to go into more like production, more scale. Now you have like tools like VLLM. This is something which, if you really like want to increase your throughput of all those models that you have trained. So I would say from the community there are a lot of things that now I would use that, and then once we test it, then go to VLLM and then deploy it on that. And that's basically what we did. And good. So now let's say we achieved those results. So now we know, okay, this is how it works. We have almost like 0% of hallucination, and we know how to deploy it. And if we need to scale it, we put also this on VLM. But our question is, okay, but is this like enough? What's now next that we can do? And there is actually, if you now go a bit more deep into this domain of large language models, there are quite a few things that you can do. So one of the things is that, let's say you have your Copilot and somebody uses it. If you, for instance, are able to collect user feedback, this is then something that it can even help you make a better model, more accurate, more consistent in your performance. So in our case, so if you see like when we generate a Copilot, now we are currently tracking feedback in the form like, okay, are you dissatisfied, satisfied? And if you have enough examples, you can use that. How, let's say GPT 3.5, all those models are trained with a complex reinforcement learning pipelines, but the recent trends are going more into this direction of human-aware loss functions. So this is basically also it's available in LLM Studio, so you don't need to like go really deep dive. There are frameworks who help you do it. But the thing is, if you have some kind of feedback in a binary format, and a lot of time, and even if it's imbalanced, so you have, let's say, more negative than positive feedback, and this is, I would say, a lot of times the case for every time when people give feedback, because nobody is gonna like. A lot of times people like to say, this is bad, this is like shit. I don't like this. And they're rarely gonna say, this is really good. But in those cases, you have this is, let's say, one paper from Kahneman-Tversky. So they defined one optimization function which showed, okay, once you, as I said in the previous slides, fine-tune your model, and then on top of that you basically tune it with the KTO optimization function. It basically gets aligns more into the direction what your users expect, because they have their own preference, they have their own expectations, which you don't have this in the data. So if you basically get enough of those feedback, then you can even make those models even better. And now, I think if you go now to LLM Studio or any GitHub, Google for that, you have an already Python code which you can use for that. And the last thing that the last thing that I will talk about are multi-arm bandits. So why are they? So this is multi-arm bandits are not something new, but their work which for several years. But remember, we talked about prompting. We talked about fine-tuning our own models. And so we did our experiments offline. So we simulated, let's say, the behavior, what we did. But you don't know which one is the best until you put it, let's say, in production online. And it could be that one model, because of seasonal patterns, let's say, works really good in winter during Christmas. Another one works better for whatever reason, let's say in autumn, and another one works for whatever reason in summer really good. You would like to have some kind of automatic mechanism which knows how to shift, let's say in this case what you see like machine 1, 2, 3, it's basically a model or an, let's say, API, a service which is deployed to, let's say, generate some kind of code. So what you would like to have in an online setting is something that automatically picks, okay, which one model now is the right to, or has the highest probability to generate something. And for that, again, the same kind of feedback that I showed previously, you can use that to learn something. And I put this at the end because you would, I think, fall asleep if I added some slide with mathematical equations, like nobody, you don't need to read it. I just put it because it looks nice. But in the next slide, I have some code because like this is not hard to implement. So what we would like to do is basically for every model now, so we had like, I don't know what, 6 prompting techniques, we had 4 large language models. For each one of them, you would like to learn some kind of probability curve, how likely that model is that the user will be satisfied. And if you have this kind of satisfaction, then let's say this is the equation that you need to solve. And when you go to Python, like, I mean, it's not that big chunk of a code. So basically, you would have some kind of update mechanism where you just, let's say, have an array for the rewards that you track, and then okay, this is, let's say, this really complex mathematical equation, but it's not that hard. I will put the slides online, so you don't need to also now type it in. But basically, this is, let's say, an example of an Bayesian UCB multi-arm bandit, and there are multiple ones. So once you go into that way, you can basically make your own automatic LLM picker in an online setting, which is able to shift, like if the next day another model works better, it will increase the probability that it will be picked. And again, like in your code, when you're at the inference time, you would have some kind of like logic. Here, give me the currently highest probable LLM to do something. You generate that output, somewhere collect that feedback, and then update it. And that's basically that. So I would, at least this is what we are doing, and that's like my recommendation when you go like to an online setting, to have maybe some kind of mechanism in that way, because even though in the beginning some prompting strategy wasn't that good, maybe today, like you sit before your laptop and you have another idea, maybe to make that prompt even better, so you would just put it in production and see, hopefully over time, that this bandit will, because it works on probability, it will have sometimes randomly, it will pick that strategy, and if it really generates good results at, I don't know, in 1 week or something, it will become the dominant solution and just automatically work. And that's it from me. I will put the slides on my website, so you can then download it today. If I forget about it, write me a hateful email at that mail, or LinkedIn spam me, I don't know, whatever you want. Yeah, but that's it from me. I mean, we have, I think, like 4 minutes for some questions, if somebody wants.
And just as a reminder, if questions are asked, just for you to repeat them
for
the live stream. Any questions from the audience?
How did we do experiments? Yeah. Okay, so I mean, we did it manually, internally. So what we did, so we a lot of time, you will have to invest a lot of time to create the data set to those experiments. This is the first thing. And then we manually implemented our own evaluation pipeline, because it's a bit domain specific. So we wanted to simulate, let's say, okay, our users are going to type something, and this is what needs to be generated. So I would say biggest chunk of work is making the right amount of data which at a certain certainty like simulates the user behavior. It's manually done. So, I mean, you have there are frameworks also, like if you go, hey, evaluate LLMs, something. The thing is here, we're generating code. So we are generating, at our example, domain-specific factual code. There's not like something out there that we can just reuse, because it's really like tied to our business logic. But if you would like do some kind of evaluations for any kind of like Copilot functionality, where maybe the output is just a text or human readable, there are a bunch of frameworks out there. Even you can use large language models as a judge, where like they say like psychologically, hey, okay, this is interesting or not. It depends really on your use case. But here we did it manually. Okay, you can also stop me later. Oh yeah, sure. Okay, so do we currently at this point have LLMs to test our product? No, but we are working on that. So this is like one. I mean, overall, I would say now the trend is going to have like different LLMs to test your products. One thing is like, okay, if maybe this whole dialogue, like these elements, it's too complex, something like that. So there are. Once you open that box, it gets interesting and complex. But we don't have it at this point, but we are working on that. Yeah. Maybe another one, and then you can. Okay. If my language model is in a state where it can be fine-tuned. How do you know? Okay. A language model can always be fine-tuned. This is this depends basically. I mean, it's your decision if you want to do it or not. In our case, we know it because we did the experiments. So if nothing would have been changed, let's say if the amount of hallucinations would be the same, this means that, okay, the model before was already okay. Usually just based on the literature, what other people are doing, it's already like prevalent that usually it helps. So a lot of times it will help, but the actual question is it necessary? So there's always a trade-off because there are some costs involved in it. Like when we did this just with prompting, okay, we asked ourselves, is it enough? But we wanted to see, okay, how much can we get more? Usually there's always something, because what you do with fine-tuning, you're grounding the model into, let's say, some specific vocabulary, something what is for your purpose specific. And in the end, it is a probability model. You're just increasing, let's say, the chance, the probability that in the end the model will really generate what you want to do in the, let's say, a lot of number of times that you're doing some kind of request. There's no guarantee, although. Now you. Sorry, I didn't explain it because so this was a parameter. So we tried different temperatures. So we tried different configuration parameters because we wanted to see, okay, what's the best prompt that we really can, on a lot of iterations of examples, generate, let's say, the best results. Here we had, let's say, the temperature 0.7. We tried different ones. But it was a bit unstable with prompting. So this is like in the end why we decided with fine-tuned models. So here we just, in our experiments, temperature was 0, what I showed you with the results. We had minor differences, and this was, for instance, interesting. There were not too many differences with respect to hallucinations and accuracy if we change the temperature parameter, because with fine-tuning, you're like grounding the model a bit more really into your data. Here the tricky part is, do you have like really quality data and the amount of it? And this is something that you have to like repeat again and to see, okay, is it getting better or not?
How do you know when you've had enough iterations?
Okay. How do I know when I?
When you've had enough iterations of testing.
Okay. So the question, how do I know if I had enough iterations of testing the model? So we have to know. Okay, last question. Okay. Basically, you would like you will track over time if it's converging. So maybe you can say like you can plot the accuracy, and then if you see like it rises and then it gets like stable, you can measure some delta. There are ways. Basically, you would see if the accuracy isn't getting any better over a certain amount of iterations, and those things can also be automated. So. And a lot of basically also those tools that I showed, they have some that are like early stopping before, like you don't need to like go that often. Yeah, thanks. I think I have to go.
Give a round of applause to Emanuel.